What's up, everyone? This is LeetCode 721 accounts merge. We've done this problem in Python. Now we're going to do it in C++. Now you're going to see over here in a little bit, it's going to say Python because I'm just going to reuse parts of my Python video for this video, only for the explanation, just because I don't want to re-explain stuff. I think I did a good job on my Python video, but the implementation I will make, obviously, a new section for this video for the C++ implementation, but the explanation, I'll just leave it. I'll just reuse the Python video's explanation, so don't mind that, okay? Don't get freaked out or anything. But yeah, I just want to tell you that. This problem is actually quite difficult, I will tell you that from the start. So I'll try and go slow and explain things as best I can without making this video too long, but here we go. So we're given a list of accounts where each element in the accounts array is basically a list of strings, where the first element within that actual element is a name, okay? And the rest are emails. So I will copy and paste this just to show you what exactly this means, okay? Okay, so what this basically up here is telling you is that we have an array called accounts, right? And within this array, we have other arrays, okay? And in these other arrays, the first element is a name, and then what follows is a bunch of email. You can see this array also, name, bunch of email, name, bunch of emails, name, bunch of emails. Well, these only have one, but you get my point. And we want to merge these accounts, and two accounts belong to the same person if they have a common email. Note that two accounts have the same name. If two accounts have the same name, they may belong to different people, as people could have the same name, right? If a person can have any number of accounts initially, but all their accounts definitely have the same name, right? So it also says, after merging the accounts, return the accounts in the following format. The first element of each account is the name, and the rest of the elements are emails in sorted order. The accounts themselves can be returned in any order. Okay, so this problem statement may be a little bit tricky, so I'm going to explain basically what this problem is asking you. So we could have two people named John, right? Let's say a young guy named John and an old guy named John. So these accounts don't necessarily belong to the same person, but they could, right? And how do we know if they belong to the same person? Meaning, how do you know? Maybe the guy who's the old guy named John, maybe he has two accounts. Well, how would we know if these two Johns are the same person or if they are different people? And that's where the emails come in, right? So because these share the same email, right? You can see John Smith at Gmail, John Smith at Gmail. We know that these Johns actually are not separate people. They're the same. So technically, this John here, he has this email and this email, but he also has other emails, right? He has this email, which obviously is up here, and this email. So they're the same people. This John is the same person. He just has two different accounts. So what we need to do is we need to merge these, right? So we're going to basically take all these emails and put them up here. Of course, we're not going to include this because it's already up here, right? So technically, when we merge, right, we're going to get something like this, right? We're going to delete this. So we did the merging. Now you can see there's another John here, but he has this email, and this email is not up here anywhere. So technically, this is what our merged account should look like, right? And let me copy this output, show you if we're correct. Okay, so this is what our answer should look like, and as you can see, that's actually what we did. So we did the merging. Now, kind of like running through this by hand is very simple. I'm just doing this to show you basically what the problem statement is asking. Actually doing this programmatically, that's kind of obviously the tricky part, right? We have a list of lists, right? An array of arrays, vector of vectors, depending on what language you're using, but that's kind of the tricky part. And how would we approach this programmatically? We now that I showed you, we kind of understand how to approach this kind of logically, but how would we handle this programmatically? Like what conditions would we check? How would we do this, right? So moving back a little bit, right? when we're here and I said, wait, this email belongs to this account, right? Well, we're gonna have to keep track of that because we need to know if an email exists somewhere else, right? And so the way we're going to do that is basically a hash map, right? Where the key is the email and the value is the account um, index, right? So that way we can kind of map certain emails to certain accounts. And if we encounter an email more than once, we know, okay, this email actually belongs to this other account, yet it also belongs to this account. So that means these two accounts must belong to the same person, and we need to basically merge them, right? And the way we're going to do a merge is through this, right? It's through the disjoint set data structure, also called the union find data structure, the merge find set, right? And so this will allow us to merge two disjoint sets because we know there's overlap. So this is kind of a good illustration, right? These are just basic discrete math type things. If you've taken discrete math, you will know. If you don't, it's okay, but like set theory stuff, right? Or for, these would be disjoint sets. If, for example, A has the values 1, 2, and 3, and B has the values 4, 5, and 6, right? There's no overlap in elements, so they're disjoint sets, right? But let's say we have something like this, right? Where let's say X has the values A and B, and Y has the values B and C. Well, there is overlap, right? So they're actually joint sets. And that's basically what we're doing is in this problem is that we're basically assuming all these are disjoint sets initially, right? And when we see this overlap in emails between two accounts, we know that they're actually not disjoint sets anymore. They're joint sets. So we have to join them and merge these accounts together, right? And that's basically what we're doing in this problem at kind of like a high level. And so the way we would do this is basically we're going to assume that all these accounts are essentially disjoint sets initially, right? So this account is its own entity, basically, right? Like John, right? John has these emails, right? So it's basically its own entity. Now this John, we're also assuming is its own entity, right? But when we go here, we see there's overlap between this and this. So when we go here, we know, wait, this actually is not its own entity. This is actually an entity of this, right? And so that's how we would do the merging, kind of like in like kind of like a more abstract way. That's basically what we're doing, right? We know, okay, this is actually not its own entity. It belongs to something else, which is this John, because these are not, again, disjoint sets anymore. Found that they share an email, right? Mary, of course, is a disjoint set, right? She does not share an email with anyone. And this other John here is its own entity, right? He's a disjoint set. He doesn't share an email with any of these Johns. So we know this John down here is actually a separate John. It's not referring to the same person here. So Mary is basically its own entity. So is this John. Okay. I know this is a little abstract, but yeah, union finds a little bit hard to explain, but I hope you can understand kind of what I'm getting at, as well as like there are other videos out there. There are more resources if you're lost, but at a high level, that's basically what we're doing. Okay, is we're assuming these are all disjoint sets, and when we find something that proves okay, these are not disjoint sets, we need to basically merge them. Okay, that's what we're doing. And by the way, that's why I said we're gonna have a hash map where the key is the email. That's why the account index, right? The account index is the value in the hash map, because an email points to whatever the account index is initially, right? So when we encounter an email initially, it's going to point to whatever account we found it on. But if we encounter that email again, it's not going to point to where we're looking at, because if we encountered it before, we know that this email actually points to whatever account we saw it before. And so we need to do something with basically all the emails for this particular account, because this entire account basically is not its own entity. We need to basically make sure it's pointing at the account that it should, which is not itself, because it's not a disjoint set, okay? Now, again, that's kind of a little bit more on the high level stuff, but you can kind of understand maybe how we're going to start to approach this, at least hopefully. You can kind of start to understand how we might approach this programmatically, even if you can't think of the code, right? All right, so this is the implementation of the union find data structure, right? This is the class. And this is kind of the tricky part about this problem, right? You have to actually implement this and then use it in the actual problem. And it's okay if it's confusing, right? If it's your first time seeing this union find stuff, just make sure you read about it and learn about it and learn about it on your own as well. But I will try and explain some of it. But this is kind of like its own topic also, right? So I'll try and explain as best I can, but you may need to use additional resources to make sure you understand this. But yeah, don't feel too bad if it's your first time seeing it and you're confused. It's okay. So, this is just set theory stuff, really, right? That you learn in discrete math. If you didn't learn this type of stuff, you have to learn it on your own. That's fine too, right? But just make sure you always learn and study on your own as well. Because you want to make sure you have a solid foundation, kind of like mathematics, right? You don't want to move on to advanced topics without making sure you understand and skip a step. You don't want to skip a step. So make sure you have solid foundation. So make sure you learn your union find stuff, right? Anyways, I'll explain this class. So we have to initialize each node, right, as its own parent. And we'll do that down here with the accounts, right? So each node basically is its own entity, right? And then we have a find method here, right, which really will just find the root parent of the node X with path compression, right? So because you could have a bunch of nodes that kind of are kind of linked together, right? And you want to find what is the parent node. Like let's say you have a node X, and then there's also a child node Z. Well, if you do find and you pass it in the Z, it'll actually do the path compression. It'll return the actual node X because that would be the parent, right? And this is actually used. This find method is actually used down here when we're doing the unite. This is the union, except I can't call it union because I think that's a keyword in C++, so I just said unite. But really, we're just unioning this child that we pass it in and this parent. So we're passing it in. We're passing in basically two disjoint sets, two disjoint nodes, and we're unioning them, right? Basically making sure that the child doesn't point to itself, but it points to the parent that we pass it in, right? So what we're going to do is we're passing a child node and we're passing in a parent node. So we're going to find the root parent of this child, and we're going to make that point to the root parent of this parent that we pass in, right? So for example, if we're unioning this account with this second account, remember, we want to, because this John Smith shows up once here, but then it shows up here again, we want to make sure all these emails basically get unioned and put here. So this would be the parent that we would pass in, and this would be the child, right? So basically this account here should point to this account here, so that we can kind of union and merge them, okay? I know maybe a little bit confusing if this is your first time doing union find stuff, but just keep it simple, right? Don't overcomplicate it. I wrote these comments here. Hopefully it'll help you. Again, you might need to do additional studying if this is really confusing to you, but honestly, just beat your head against the wall trying to learn this stuff, metaphorically, right? And it'll make sense. Like, I had to watch and look at a bunch of different resources till it started to slowly make sense. And make sure you remember those illustrations that I showed you, right, with the nodes. But yeah, this is basically the union find stuff that we implement, and you are going to have to learn this because there's a lot of union find problems that actually require you to implement this before you can actually start to solve the problem. So this is just like a data structure, right? Just learn it, keep it in your back pocket, and you'll be fine. All right, now that we got the explanation out of the way, we can do the implementation, and we will go a little bit slow, right? Just so you're not lost. So first of all, I'm going to write my code as simply as I can so you can follow along. So we're going to get the number of accounts by doing accounts.size, right? And then we're going to create a union find object. We'll call it UF, and we'll pass it in the number of accounts for basically the number of nodes, right? Because each account, you can think of it kind of like its own node. Right, because every node or every account has a list of emails, and if we find another node where we have like overlap, we want to make sure that we basically have that other account point to the account that it should rather than itself. Because if two nodes or two accounts share an email, we know that technically it belongs to the same person, so they're not independent, right? They're technically belong to the same person, so technically those two nodes should be linked in some way, right? So first of all, let's make a hash map, right? Called, we're gonna say unordered map. We're gonna pass it a string as its key and a integer as its value, right? We're going to call this email to account, right? So this basically maps email to account index, right? Like I was talking about at the start of the video, where the key is the email, right? And that maps to whatever account, the account index that we saw it at. That way, if we see an email more than once, because we can do a fast lookup using the key in the hash map, if we see an email that already exists in the hash map, we know that, wait a minute, this email, we already saw it somewhere else. So that means there is some overlap somewhere between two accounts, right? Okay. So, now what we're going to have to do is we're going to have to build the union find data structure based on shared emails, okay? And I'm going to explain how we're going to do this. So we're going to have a for loop, right? And we're going to say int I is 0, I is less than num accounts. I'm going to say I plus plus. So we're going to go through, and maybe I will actually just copy this and put this here, just so you can kind of follow along a little bit easier. Right? So we're going to have two for loops. Right? Now, this outer for loop, what we're doing is we're iterating through the actual accounts, right? So we're going through this account, then we're going through this account, and then we're going to this account. However, when we're on a specific account, we need an inner for loop so we can actually iterate through these, right? So we can actually go into the values. And that's what this inner loop is for. So this outer for loop is just to basically go account by account. And then this inner loop is for that specific account. We want to actually look at stuff within this array, right? So we're going to say for int j is equal to 1, j is less than account of I dot size, and we're going to say j plus plus. Okay. So we have to do it this way, okay? And so why are we doing j is equal to 1, right? And I can just put that here actually. So I'm going to say the 0th index is the name, not an email. So skip it, right? Because we want to, when we're looking at this hash map here, right, we want to see, okay, does an email exist? This email that we're on now, have we encountered it somewhere else before, right? Like when we're here, we basically should have a way to say, hey, we already saw this email up here, right? And so we only care about the emails because that's how we know whether we should merge something or not, right? So we want to skip the name. So we don't want to start at index 0, we want to start at index 1, okay? We only care about the emails right now. So we can have two conditions, right? Using this hash map here, either we encounter an email that is already in the hash map, so we've seen it before, or we encounter an email for the first time, right? Those are our two conditions. So let's do the first thing, right? So we're going to say, first of all, let's grab the email, okay? Again, I'm just writing this all super explicitly so it's easy to follow along. We're going to say string email accounts of I at j, right? Because again, the j starts at 1, so we're starting here and we're going all the way forward. We're starting here and we're going all the way forward. So we're only grabbing emails. Let me put this here. We're only grabbing emails, right? So we're going to store this email in a string and we're going to check, does this email exist as a key somewhere in the hash map? Yes or no, right? So we're going to say if email to account dot count email, right? Email already seen before. If that's the case, we need to do a union, right? So we're going to say uf.unite I email count email. Now I'm going to remind you why we have to do it this way, right? What are these parameters anyways? Well, remember, the first parameter is the child, and that child should point to this parent, which is the second parameter. The email that we're on right now is at the current account index. The current account index is I, right? That's the account that we're on. but this is the second time we're seeing it. So that should be the child node. The account index, that should be the parent that we want to point it to, which should be the second parameter. That is stored as a value in the hash map already, right? Because we already seen it before, and we already added it to the hash map some point before. So when we're passing it this email into the hash map, we're getting the account index of where we saw it the first time. So for example, when we encounter this John Smith here, this is the, maybe I should do it down here. This is account index 1, right? So that's what we're passing as a child. However, when we added John Smith to our hash map, when we saw it here, the account index is actually 0 the first time we added it. So that should be the parent. So when we do this, we're passing in 1 as the child and 0 as the parent, so that this 1, right, this account here, when we do the unite, it should point not to itself but to this account, right? And so that's kind of how we're doing the unioning or the merging of these accounts. Okay, I hope that makes sense. I think the explanation's okay, but again, if you're new to union find stuff, maybe a little bit confusing, make sure you brush up on that stuff, especially if you're new. It's a little bit confusing at first, so don't feel too bad. Okay, now here is the case where basically, right, this email has never been seen before. Add email as a key, account index as a value. Okay, so we're going to do email to account. The email is the key, and the value should be the account index, which should just be I. Okay, and that should be it so far, right? So that's it for now. Now we have to do something else. Okay, now I want to show you something with, we did this unite stuff here, right? We built out this hash map here. I want to show you something, okay? So we're going to use some print statements. So we're going to iterate through this email to account hash map we already have. Okay. We're going to say for const auto. Remember, our key is the email. The value is the account index. And we're going to iterate through email to account. Okay. So we're going to do some print statements just because I want to show you something really interesting, right? So the email that we're on right now, we're going to print that. Okay. Additionally, we're going to print the account index. Okay. And this should be this. And then here we're going to print the leader index. Okay, we'll just call it leader index. I could just call it leader, but we'll call it leader index. And we're going to do uf.find and pass it the account index. Okay, and we're going to have this here because this problem expects a return statement. So if I remove this, we're going to get an error. By the way, I fixed this up here. I called this num account, and then right here I said num accounts. Here I had num account as well. So make sure it's consistent. Just rename this to num accounts. Num accounts, num accounts. Just the tiny little syntax error, but so sorry about that. So we're printing this now. I want to show you something. Okay. So we're just iterating through the hash map and printing out the email, the account index, and also we're doing this uf.find, passing it the account index. Okay. So I want to show you something. So this Johnny Bravo here, right? The account index is 3 and its leader index is 3, which makes sense, right? There's no overlap with this email anywhere. So technically it's its own account. This Mary, same thing. There's no overlap with this email anywhere else, so it's its own account. Now, when we go here though, this John00, this is interesting. So here, what account index does this email belong to, right? This is one John, and this is the other John. So this John here, this account is account index 1, right? So the account index should be 1 right here. Yet when we do the leader index, it's 0. Well, that's interesting, right? Why is that? Well, because when we encountered this here, this is the second time this email has showed up, right? It showed up in account index 0 right here. And when we're in account index 1, it showed up a second time. So we did the union, right? The unite thing. And what that did was basically it basically takes this account and it no longer points to itself. It now points to its parent, which we said before is this one, right? Because we pass this in as a second parameter. So even though this account initially is at account index 1, it should point to this index, leader index, which is 0. So we can use this to basically construct an account where this is tied to this index, the account index 0, instead of the account index 1. And so we can construct these emails now and tie them to the proper account. And that's what we're going to do. It'll help us construct our output, right? So why don't we do that, right? And also, really briefly, John Smith at Gmail here, the account index is 0 and the leader index is 0, right? Because when we encountered it a second time, we didn't add it to the hash map or append it or do any of that stuff, right? We just skipped it. All we did was the unite stuff. And the unite stuff is really to set up all the other emails for this account and make sure that they point to the proper account rather than itself, right? And they point to the proper account when we do uf.find and pass it the account index. So when we do uf.find for this account, right, it returns what index? It returns not itself, but it returns this index because this is the parent node now, right? And that's what I was talking about with the child nodes and the parent nodes, right? All nodes initially are technically disjoint sets, right? They point to themselves. But when we do this unite stuff, we basically have the child node, and now it no longer points to itself, right? This account here no longer points to itself. It now points to here, right? So now we can construct, now you can see how, hopefully, how we can construct an account with all the proper merged emails, right? And of course we have to do that manually, right? Which is what we're going to do now. So we're going to create a unordered map up here, right? Where the key is the account index and the values are the emails, right? So we're going to say vector of strings and we're going to say account to emails, right? The account index is now the key and the emails are going to be the values. And so we're going to construct our merged emails now to the proper accounts. Okay, so we're going to say int root. You can call it leader. I'm just going to call it root. It doesn't really matter. Whatever variable you prefer to use. We're going to say uf.find account index, right? So we're basically grabbing, because remember, we're in this for loop, we're iterating through the hash map. So for this email right here, we're grabbing not the account index, but the proper account index that it should point to, right? So here, for when we're iterating through the hash map and we're at this John here, we're not grabbing this account index that it's at, but where it should point to, right? So we're getting this index 0 for that example, okay? And we can do that by basically taking that root as the key. So we're going to say account to emails, root, and then we're going to do dot push back email, right? So you can see that we're now taking this John00 mail right here, right? We're taking this guy here and we're creating basically an account where we're putting him up here, right? Instead of down here. So we're going to create basically an account manually of all these emails in addition to this guy, so that we're going to have something like this, the output, right? A merged, bunch of merged emails. Okay, that's really what we're doing. Right? And maybe I'll just write a comment. We're going to say group emails by root parent account, right? Okay, so that's pretty much it, right? We're building that out. Now we have to actually, because we're really mapping, right now we're just mapping some account index to a bunch of emails, right? But that's not what our output should look like, right? Our output is technically a array of arrays where the inner arrays are basically the name and a list of emails, right? So we can't actually return this. We have to do something a little bit different and then return, okay? That's what we're going to do right now. So remember, array of arrays, right? So we're going to say vector string, and we're going to say merged accounts, right? And we're going to return this down here. Okay. So we're going to iterate through this up here that we just created, the account to emails, right? So we're going to say for const auto. And remember, the key is not the email now, but the key is actually the account index. And the emails are the values. Okay. So we're going to say account to emails. Okay. So when we build this out, right, look at our output. We have to first get the name, then get the emails, right? Get the name first, and then get the email. So we're going to say string name, right? And we're going to say accounts at the account index at 0, right? Because for every account, right, remember that the 0th index is the actual name. So we always want to grab the 0th index for any specific account, right, to get the name. Now, the emails is where it gets a little bit tricky, right? Because we need to sort these, right? Because for some reason, that's just what this problem wants. The accounts themselves can be returned in any order, right? So this account can come first, or this account can come first in our output. It doesn't really matter. But these emails within the accounts have to be sorted in a specific order, okay? And so a little bit annoying, but that's just what the problem wants. So we're going to say sorted emails. I'm going to set this to emails. I'm doing everything explicitly so that it makes sense. We can remove this, by the way. Or not. That was just for testing the print statements. So we're going to do sort, right? And we're going to do sorted emails dot begin, sorted emails dot end. Okay, we're just sorting, right? We're just grabbing the emails, putting them in this variable, and just sorting them. Okay, I'm doing everything explicitly so it's easy to read. Okay. And now we want to basically create. We're going to create a vector of strings, right? And we're going to call it merged. Pass it in name. Okay. Now, why are we doing this? Because remember, our array or our vector for the account is, it has to be first the name, right? And then all the emails, and the emails have to be sorted, right? So this is what our vector has to look like. So we're going to take this, we're going to construct this, and then we're going to put that in merged accounts, right? So that we can create every account in its proper format. Okay. So we're going to say merged.insert, merge.end, right? Because we added the name. And we have to add the sorted emails, right? So we're going to say sorted emails.begin, sorted emails.end, semicolon. And then we want to take this and push it back to, or not, sorry, we want to take the merge and push it back in the merged accounts vector of vector. Well, it's a vector which contains a vector of strings. Okay, just like that. Yeah, this part is a little bit tricky, but it's just basically the we're basically just build the final merged account result, and it is a little bit tedious just because they want our output to be in a specific order, and so we just have to follow those rules. But I hope you're following along. I don't think I'm being too confusing, right? So it should be good. I'm gonna submit this. And, you know, with my comments, I tried breaking down what we're doing step by step. So I hope you followed. If it's your first time doing this problem, I'm not going to lie to you. This is a little bit hard, especially if you're new to the union find stuff. I'm going to zoom out a little bit so it's easier to see. So this is our union find stuff, right, that we implemented. Here, we're basically unioning wherever we see some emails that overlap with another account. And creating our hash map where we map the emails to the accounts. And here we're basically just grabbing our emails, right, and mapping them to the proper account index. And then here we're constructing our output where we have to have the name first and then the sorted emails after. Okay, so when I put it like that, the problem is really not too difficult in the sense that it's pretty straightforward, but it is a tricky problem. I will give you that. I couldn't solve this by myself. I definitely had to have help, so don't feel too bad if it's a little bit hard for you. I think that's kind of expected, especially if you're new to union find. I hope this print statement here kind of shows you why this is so important, right? But I hope this helped you. But yeah, sorry for the long video, but like I said, like this is a tricky problem. So I really do have to over explain. Otherwise, I feel like you'll just be lost. But I hope you learned something, and I hope this was useful. And I'll see you in the next one. Peace out.